Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faris Rizal bin Muhammad Jamal, and I will present my final year project. The title of my final year project is Development of Epileptic Detection Sensor for IoT. First is introduction about the epilepsy. What is epilepsy? Epilepsy is a central nervous system neurological disorder in which brain activity becomes abnormal, causing seizures or period of unusual behavior, sensation, and sometimes loss of awareness. Anyone can develop epilepsy. Epilepsy affects both males and females of all races, ethnic backgrounds, and ages. Seizure symptoms can vary widely. Some people with epilepsy simply stay blankly for a few seconds during a seizure, while others repeatedly twitch their arm or legs. Having a single seizure doesn't mean you have epilepsy. At least 2 unprovoked seizures are generally required for an epilepsy diagnosis. There are few symptoms of epilepsy. First is temporary confusion, second is a staring spell, third is an uncontrollable jerking movement of the arms and legs, fourth is loss of consciousness or awareness, and the last one is physical symptoms such as fear, anxiety, or deja vu.
Seizures that appear to involve all areas of the brain are called generalized seizures. Three types of motion seizures is tonic-clonic. Tonic-clonic cause stiffening of your muscles. These seizures usually affect muscles in your back, arms, and legs and may cause you to fall to the ground. The second one is the clonic seizures. Clonic seizures are associated with repeated or rhythm jerking muscle movement. These seizures usually affect the neck, face, and arms. The third one is the tonic-clonic seizures. Tonic-clonic seizures, previously known as a grand mal seizures, are the most dramatic type of epileptic seizures and can cause an abrupt loss of consciousness, body stiffening and shaking, and sometimes loss of bladder control or biting your tongue.
Next one is problem statement. Even technology has become advanced each day, there are so few seizures detection devices, especially for the movement seizures, exist in the market. Most of the device is by video monitoring the patient 24 hours, and it can give false result when the patient happen get the seizures when no one around. Even the device for GTCS has been made, the problems also tends to happen when it hard to differentiate seizures from normal daily repetitive movement. Overall, there are the few problem statements were found. First is hard to differentiate seizures from normal daily repetitive movement, and the second one is seizures are not detected when there is an obstacle to free limb movement. Next is objective of this project. 3 objectives for this study has been proposed as below. First is to collect accelerometer sensor data in several conditions, which is walking, running, and shaking. The second one is to collect gyro sensor data in several conditions, which is walking, running, and epilepsy. To determine which sensor are the most suitable in detecting epilepsy is the last one for the objective. Next is methodology. First one is hardware. In a development of hardware, the system consists of electrical part and software parts. Not MCU was the microcontroller used in the system. This microcontroller comes with the ESP8266 Wi-Fi module to connect the microcontroller to the internet. The MPU 6050, which contains accelerometer and gyro sensor, will act as a main component of this project. The result of this project is determined by the movement of the sensor in 3 conditions, which is walking, running, and when having a seizure. After the hardware was set up, the Not MCU microcontroller was connected to the PC using the USB cables. The Arduino IDE software was used to create a system program. The program was coded using the C programming language. Then the coding was verified and uploaded to the Not MCU microcontroller. blink application was used to get a result. Next, I will explain about the flowchart. First of all, the user need to connect NotMCU to PC by using USB cable. Then NotMCU microcontroller must connect to mobile phone via Wi-Fi connection. For this, you have to turn on the Wi-Fi connection on mobile. So the main wireless controlling technique used in this project is Wi-Fi technology. Wi-Fi receiver will be connected to NotMCU module. Android mobile user has to install Blink application on his mobile handsets. By that, open Blink application to get the result. Before that, Blink application has been set up so that the result will be shown in graph by using MPU 6050, which has accelerometer sensor and gyro sensor. The sensor will be conducted in several conditions, which is when user is running, walking, and by the time user having a seizures. Next is result. In this section, the discussion about the accelerometer sensor data and gyro sensor are being explained to achieve the objective of this project, which is development of epileptic detection sensor for IoT. Both sensors are tested in several conditions to get different output by using MPU 6050, which contain accelerometer sensor and gyro sensor. Both data are collected simultaneously. By this experiment, we will see which sensor will give more accurate and stable data. Both sensors are tested in three conditions, which is walking, running, and shaking. In this part, I will explain about accelerometer sensor vs gyro sensor while user is walking. Left picture show that accelerometer data while user is walking. It clearly show x-axis in red lines, y-axis in white line, and z-axis in green line. Compared to gyro sensor data, accelerometer sensor give more stable data. As gyro sensor data, we can see that there are spike-shaped graph. As logically, the hand movement when walking not so fast. According to gyro sensor data, it might be confused between walking or doing repetitive movement. Next, I will explain about the accelerometer sensor vs gyro sensor when user is running. As we can see, both picture is accelerometer data and gyro data. Even though we're running, accelerometer give more stable and accurate data compared to gyro sensor. It is because that the accelerometer data sensor data shown that there are no aggressive hand movement while running, while gyro sensor data show that it's almost as same when user is walking. Next, I will explain about the accelerometer sensor vs gyro sensor when user shaking their hand movement as having seizure. As we can see, accelerometer data give a spike-shaped movement because the hand movement while shaking is aggressive. The seizure patient usually shaking their hand very aggressively when they're having a seizures. When we looking at gyro sensor data, we can see that there are unstable data that shows. By comparing these two data, we can clearly say that accelerometer data sensor give more accurate and stable data compared to gyro sensor data. Okay, next we will comparing accelerometer sensor data between walking, running, and while user is having a seizure. So we can see from the left picture, we can see the user is walking. The middle picture is while the user is running, and the right picture is while user is having a seizures. Compare these three pictures, we can clearly say that we can see a difference between walking, running, and seizures. And the last one, we will comparing gyro sensor data while walking, running, and seizures. As we can see at the left picture is gyro data while walking. The middle one is the running gyro sensor data, and the last one is gyro sensor data while having a seizures. As we can see, between walking and running gyro sensor data, there is slightly different graph, and by comparing these two data, it might be confused that user is walking or running, as gyro sensor data while having a sedges. We can see that there are few flat graph shows and there are unstable data. So the conclusion of this project is development of epileptic detection sensor for IoT applications successfully determined the best sensor between accelerometer sensor and gyro sensor by comparing these two sensors in several conditions. In each condition, accelerometer sensor show more stable and accurate data compared to gyro sensor data which is unstable. By following this project objective, accelerometer sensor has been chosen as most suitable sensor in detecting epilepsy. The objective of the project has been successfully achieved. The future work is to develop the real device, which is to be tested by a real patient to get more accurate data. The reason is that this project is only tested by a normal person who not had a seizures. However, the concept of bringing this project into real application may be useful in the future. Thank you.